Welcome back. In this final lesson of the section, we will revisit some of the main takeaways for the exam. This is meant to serve as a summary of the section. Starting off with scalability. Remember that scalability refers to the idea of a system in which the infrastructure can be expanded or contracted to meet the decrease or increase of the workload demand. And we have two types of scalability. We have horizontal scaling and vertical scaling. Remember that vertical scaling refers to the idea of increasing the capacity of a single node. An example of this would be to replace your T2 micro instance with a much bigger instance, like a C5 AD large instance. Remember Little Bob versus Big Bob. Horizontal scaling, or scaling out, is the ability to automatically add systems or instances in a distributed manner in order to handle an increase in load. With horizontal scaling, we get the added benefit of also increasing our availability because we are spreading our risk of failure to more instances. Speaking of high availability, don't forget that the main idea of high availability is to reduce single points of failure throughout our systems. We don't want to depend on one of anything to allow our applications to continue operating. We can use things like auto-scaling groups, load balancers, and distributing our workload to more than one availability zone to increase availability. Auto-scaling groups are a collection of EC2 instances that are treated as a group of instances that can scale up or scale down based on demand. When we add EC2 instances to our auto-scaling groups, this is referred to as scaling out, or by removing instances when the workload no longer requires them, otherwise referred to as scaling in. With auto-scaling groups, remember from the lab, we configured a minimum, a desired, and a maximum of EC2 instances we wanted for our workload. Remember that the auto-scaling group can detect an issue with an instance, replace the instance with a healthy one, deregister the unhealthy instance, and then proceed to registering the new instance with a load balancer. We can define scaling policies, which define how our auto-scaling groups will behave. These are simply rules, and these rules will define how our auto-scaling groups will add or remove instances from the groups. Don't forget about the different scaling policies we covered, like manual scaling, in which we define the desired capacity manually. There's also simple scaling, which is simple in nature because you define a rule based on a metric. Also, we have step scaling, which is similar to simple scaling, but lets you define the rules in more detail based on the alarm that was breached. And we have target tracking, which lets you define a target value. And finally, don't forget about scheduled scaling, which is based on a time which we configured to work around the workload needs. Now, we also have the elastic load balancers, which are tools that we use to automatically distribute incoming traffic to multiple targets like EC2 instances, containers, and IP addresses. And we can do this across availability zones within a region. Don't forget the three types of elastic load balancers we have, like the application load balancer, which operates at the layer 7 of the OSI model, which is what we call the application layer. This type of load balancer is ideal for advanced load balancing of HTTP and HTTPS traffic, or basically website traffic. And the network load balancer, which operates at the layer 4 of the OSI model, which we call the transport layer. This type of load balancer is ideal for TCP and UDP traffic that can handle millions of requests per second while maintaining ultra-low latency connections. And finally, we have the classic load balancer. This type of load balancer operates at both layer 4 and layer 7 of the OSI model. Since this type of load balancer is becoming deprecated, it shouldn't really show up on your exam. Now, don't forget about DNS, or the Domain Name System, which is a translator for domain names to IP addresses. And Route 53 is a managed DNS service, which offers services like domain registration, hosted zones, and health checks to our instances. Route 53 also offers routing policies like Simple Routing Policy, which provides a simple DNS response to a client PC with the IP address to the associated domain name. We also have Weighted Routing Policy, where we can assign a certain percentage of the traffic to go to one instance and the rest to another. We also have Latency Routing Policy, where Route 53 will direct you based on the lowest latency route to resources. And finally, we have the Failover Routing Policy, where we have more than one IP address associated to a domain name, and Route 53 will use health checks to verify that the primary instance is healthy, and if it's not, it will fail over to the secondary instance. That's it for the section summary. I'll see you in the next section.